All right, we're on time for away for our next. This one is some nice IoT with GE Digital. We have Tripp, Andrew, and Geetas, and I'll hand it over to you guys.
So good morning, everyone. I'm Geetas Rukis. I think the way we're thinking about this is I can just provide a little bit of an overview of what Predix is and what GE Digital is doing in this space, and then you guys can follow on with the relationship and some more details. So GE Digital is a new division within GE, relatively new. I represent Predix, which is the platform for building applications, so industrially oriented applications that are targeting manufacturing use cases as well as use cases in other industrials such as power, oil and gas, aviation. We also have customers working in building services. We're talking to customers in the automotive space. So we're looking at this as being broader than just services provided to the customers and the businesses within GE. We've been in market since February of last year. So we are a cloud platform that also has capabilities on the edge. So we can take and gather information from customers' production facilities, manufacturing facilities, operational environments, oil platform in the North Sea, a power plant, a wind turbine, or wind farm, if you will, a fleet of wind turbines sitting out in the ocean offshore. So what we do is we actually pull data in from those through sensors, through gateways, through servers, bring the data back in, allow people to do predictive analytics around that information for maintenance purposes, operational optimization, things of that nature. A couple of things where we differentiate ourselves from the standard infrastructure as a service platforms. We're all about industrial assets. So if you think about the difference that we have is we've got years, decades of experience in the industrial space. So a lot of the knowledge around how assets work together, how industrial assets integrate and operate with one another is something that sort of differentiates us. We have a store of analytics that are specific to the industrial space that can be applied. Traditionally, they've been applied very much in specific verticals, but we're seeing the opportunity to apply those analytics across different verticals. And one of the concepts we talk about extensively is this concept of a digital twin. So it's the ability to create a digital representation of a physical asset. Taking together data coming off that asset, applying analytics, all built within an asset model that brings it all together. It's not just how the asset has been built or designed, but it's how it's been operated over the years. We've got a lot of experience in that internally, and now we're looking to build a platform where third parties can bring their knowledge to the platform, as well as third-party customers outside of the GE traditional customer base can take advantage of the platform. A couple other things I've talked about: the edge, so the ability to operate. I think the term here is hybrid IT that we're using here at the conference, and so really it's about having a hybrid IT environment where we can run those analytics, build those twins where appropriate, be it again out in the operational environment where you've got very high latency issues, or bringing that information back to the cloud and operating in the cloud. Lastly, just a quick comment before we turn it over is security and compliance. Those are issues that are very, very high in terms of priority for the GE businesses and for our customers. If you think about the regulatory requirements around who has access to information around jet engines, those are some of the highest standards that you have in the world today in terms of data policies, who has access to data management. And so we have a whole set of controls that we've developed traditionally around the GE businesses that we're now integrating as part of the platform. So it's the ability to track and understand how people have been managing, who's been accessing data, how that data has been updated, and basically doing a bunch of logging, as well as the traditional stuff around encryption and all the things you want to do to make sure that data remains secure in today's environment. That includes industrial protocols. So you want to think about the traditional IT protocols and firewalls that work with traditional IT data. We also have industrial data, industrial protocols. That's a whole different set of information and how that information flows. And so we've got firewalls that are industrially oriented and specific to the needs in the industrial space. So in summary, we're an app platform, truly a platform. So it's open. We have 40 different microservices available today on Predix.io. Only about half of those have been developed by Predix. We've got a bunch of those that have been developed by other GE businesses and then third parties. We have 140 analytics that are available there, and that continues to grow. And so it's basically a platform that will allow people to build applications that address industry-specific use cases. So that's kind of the overview on what Predix is. I don't know if you guys want to add additional comments, maybe?
And just to add to this, so Tripp Partain, I'm the CT supporting the GE account from an HPE standpoint. So as we look from an HPE and partnering with GE around the Predix platform, three main things kind of surface up just from a general standpoint. One, of course, is as you look to power solutions at the edge, what are the types of compute capabilities that are required, and what are the types of environments is it going to go into? And as you guys know already, and as you heard from the other announcements with our Edgline Converged Systems, they're really ideal for those types of environments and for those types of solutions. So obviously, from a partnership standpoint, we work to make sure that we're certified and can run all of the Predix software as well as other third-party software, which could be enabled at the edge for certain use cases. It could be part of the Predix stack. It could be one of your recent acquisitions, things like Bitstu or Wise.io, or could be a business unit specific application which has not yet been ported over to the Predix platform. Right? So we work very tightly with GE Digital on those sorts of integrations at the edge, and then in a hybrid IT fashion, if a customer has a mix of how and where they need to run things, some things are in the cloud, some things are on premise, some things are at the edge. What does that look like? How does that get configured? Then also, how does that support work? And so being able to have our support services integrated with GE support services, so for the customer, it's seamless across what could be a fairly complex environment, mixing IT and OT, to make sure that we are still able to offer that, at the full level of service that a customer would expect from GE or expect from HPE.
All right, I'm gonna breathe deep because this is a complex topic. Let's start at all the way at the bottom, the edge. What are you guys doing when you say you work with non-GE assets as well as GE access? What are you guys doing to kind of normalize and present to the business consumer IoT data that they can make actionable?
So, that's the whole premise of the Predix platform, right, from a cloud standpoint. When you think about running any asset, irregardless of GE owned or not, right, the whole point is the sensors that are embedded on that asset should be producing some sort of bits or bytes that you can consume and interpret, right? What you have after that sensor is then an industrial control system that is really the brains of how that asset performs. And what's missing is the analytics to tell that industrial control system what to action on. So what we're doing is that edge solution is to normalize the data that is interpreted by the industrial control system that then creates an action for that asset to do. Our solution is, hey, when you need to run something that's maybe lightweight or a fairly low latency mission critical action, that should run at the edge, and it should be normalized based on the bits that come off of that sensor, irregardless of what sensor that is. When you need more time to process that analytic or that analysis, send that back to the cloud, use the compute power of the cloud, and maybe you can deal with a little bit more latency to get that answer back and then make that decision, again, with the industrial control system. But our goal is that the bits and bytes that have originally come off of that sensor should be, irregardless of GE asset or not, still just bits and bytes that we interpret through our edge solution.
So let's talk a little bit more about that industrial controls solution. Is that a GE provided solution, or are you guys relying on the industry at large and the standards available and products available at that control point to collect the data, then you guys normalize it and talk to like TNS and how that plays into this whole solution?
Yeah, industrial control systems are an industry standard, right? Think of a nuclear power plant. There's an industrial control system that GE provides as part of our product offering. Similarly, our competitors in that same space would have their industrial control systems that they apply to their own assets. And so this is already an industry standard. There's already policies and governance around industrial control system management. And so that's what we're relying on, is that those standards and those product offerings already exist. We're now applying the smartness and the intelligence with the edge solution to help that industrial control system make decisions. Right now, they're very reactive. They're binary. If this, then that, right? We want to give them, hey, if you start to see this, predicting what you might want to change or maybe make the asset do something different, that's where the edge solution comes in. But normalizing already has happened on industrial control systems.
So aggregation of industrial control solutions at the manufacturing level, is there a use case for that on saying, okay, we have two different operating environments or control systems that are related in the overall manufacturing process, and we want to add some analytics to that? Do you guys have those types of use cases, and does Predix offer that normalization across those control systems?
Absolutely. So take an energy utility company, right? They're probably producing energy in a couple of different fashions. You may have a wind farm, you may have a nuclear power plant, you may have water gen, a turbine, right? And so those all have specific industrial control systems based on the asset category or the asset family. And so what Predix is doing is allowing for that utility company to look across those three different asset classes and interpret, hey, what's the best power output and efficiency that I can get? And the basically the edge solutions will be applicable to those asset classes, but that's where the platform comes in. So when you actually build your application on Predix, it allows you to pull in those data sets to make a holistic view of your entire energy output for that utility company. And it can determine, hey, based on consumption, should I produce more water? Should I, turn the wind turbines or wind farm on to produce more energy out of wind? And they can make those declarations theoretically on all of those data sets.
Yeah, just to add to that a little bit, we have a piece of software we call Predix Machine, which is basically the mechanism to do that aggregation and to move the data back and forth between the edge and into the cloud. It also provides an operating environment where analytics can be run or can be developed in the cloud, pushed down to the edge, operated on the edge. So we've built in it's specific software that we have developed as GE. An important note here is that it's in use not only with our traditional GE businesses, but one of our marquee customers is Schindler. They're an elevator escalator company, right? We're working with them right now, and they've looked to us because they're looking at us to provide the software. They're running on their hardware for the specific elevator infrastructure. They have third parties that they're working with from a server architecture capabilities, but they've looked to us to provide that software layer, right? So there's clearly a need in the market for somebody to abstract up, provide an environment where those analytics can run, provide the connectivity necessary to move data back and forth, and aggregate that information. So it's very much real today, and we've got it in market with several of our customers.
And if I could quickly add, there's a proof of value that we did together with, and I can't say who the customer is, but you'll probably be able to figure it out. It's a large consumer goods company. They make a large amount of baby products, among other things. And so one of their factories, they had two lines.
Diapers.
Yeah, they have two lines that were producing diapers. And what happened is they would do, and this particular use case was around energy management. And so what was happening was they would estimate at the beginning of a year how much energy they're going to use. And if they go over or under too much, they get fined. So what would actually happen toward the end of the year, if they were getting too close on energy consumption, they just shut the line down because it was better for them to stop producing than to go over and pay the penalty. And in that environment, there were already energy management systems. There were PLCs that were on the line. There were ERP systems. There was lots of data, but none of it had been integrated. And so what we did together was we pulled the data together, we looked at it holistically, and actually came up with an energy consumption per diaper. And what they actually found out was, even though they thought it was two identical production lines, one was twice as efficient as the other. Once you understand that, and you're able to gauge and estimate on a per diaper basis what your energy consumption is, instead of just running, and oh crap, we're getting close on energy, shut everything down, you can start to work between your lines. How fast am I running? How often am I running? Balancing your actual utilization of that energy as you're producing, still stay under the consumption, but actually have much more output coming out and not having to shut a line down, which seems kind of silly in today's age that you would go, well, the best option is just stop producing diapers so we don't pay the penalty. And these are all systems that exist and have been pulling data, but not together, not looking holistically across and saying, okay, how do I define the problem, and then what can I do from an optimization standpoint to still achieve the energy levels I need, but now have many more diapers coming off the line. And oh, by the way, we also learned that one line is twice as efficient as the other, and now we can go make tweaks to get that corrected as well. So an example of existing systems, may or may not have been GE,
Yeah.
pulling that data together and then being able to use that and then automate that and then drive outcomes in real time as you then go to production.
So my background is the IT space, and you would think a lot of these solutions have been solved, and in some cases they have been in silos. But I think what we've got with the ability of cloud computing now and technologies to actually break through some of those silos, and even this consumer goods company, right? They've made acquisitions along the way. They've got different types of infrastructure, different PLC systems, different control systems that come from different vendors. They don't typically change stuff out. Right. I mean, when I worked at Microsoft, we would complain that small businesses didn't, turn their laptops over, until 5 or 7 years. Right. These guys hold on to this stuff for decades. Right. And so there's a lot of data that's trapped in there, or they've had very much serialized processes. And so what we're trying to do is we're trying to inject together some technology that allows you to aggregate that information, break down the barriers, and more importantly, create a platform. It's an open platform. So we'll be talking about a lot of use cases, but this consumer goods, I mean, it's not a GE business, right? It's a place that HPE's got some strength. So thankfully we've got a partnership with them, but this is not just about making our businesses more, it is about making our businesses more productive, and that Anthony spent a lot of time doing that internally within GE, but it's also extending it to our customers and to the world at large.
Yeah, so going along those lines, it seems like one of the big opportunities you guys have is bringing IT and OT together. These have been two separate worlds for such a long time. I come from the IT side. I almost never touched manufacturing, MES, SCADA, all of that stuff was somebody else's responsibility. I'm curious how you come together for kind of these, in a partnership perspective, for some of these joint exercises when it seems like nobody's in charge of bringing IT and OT together.
Yeah, I'll start with this one. And so what I started doing early on within our partnership actually is, if I've got an industrial company coming in to talk to HPE, let me back up one step. What we found, one thing is we have a lot of similar customers. And for us, we have a lot of similar big customers. And we don't talk to any of the same people. Right? I mean, GE really focuses on the operations side of the house, and then we really focus. So HPE has a lot of relationships in the C-suite on the IT side, and GE vice versa. So what we've started doing as customers start to look at how they're solving IoT problems is it's really starting up on both sides. You've got conversations happening on the OT side, you've got conversations happening on the IT side. So I started inviting GE operational solution architects to come to the executive briefing visits when we have the IT teams coming in. Because as much as I can say, oh, you know, BP is a huge customer of HPE and we've worked with them for X number of years, somebody starts asking me about upstream and downstream, I'm an IT guy. I'm going to glaze over and I'm going to say, well, but let me talk to you about Edgline, right? Because that's kind of the world I live in. So I've started bringing in the operational experts to have that business conversation. And then when you start then saying, okay, well, how do I implement this in my environment? Then that's where the HPE side comes in, because we're like, okay, well, we understand your standards. We understand the way your environment's configured. We've already got certified solutions working with GE at the development side, so we know which pieces from our portfolio we can pull from. We know which GE Predix components already run on there, so we're able to accelerate the IT side of it. But honestly, as an IT company, my goal now is to try to have the business and the operational conversation. Because if I'm trying to talk to any industrial about the technology, then I'm missing the point. Just like with the consumer goods company, they needed to figure out how to solve the energy usage problem, not which technology from HP is really cool that I can apply there. That was the how do I get this done piece. The real problem was, how do I solve this business problem that I have, right? And so for an IT company, it's a little bit more challenging, but that's what, you know, I'm really relying more on my partner to help me have this operational conversation.
And I would just parlay that and say that there's, on the opposite side of that, think of OT, right? And especially when you get into data sovereignty challenges, right? Generally, that has been solved by the IT community, aka HP. And HPE has come to help us figure out, hey, what's the best way? Because a lot of the countries that we have industries in do have or are starting to create these data sovereignty rules and regulations. And so we leverage them to come in and help us figure out, hey, what's the best solution? What kind of hardware do we have available within the region? How can we work with Predix to deploy in region to manage or to meet those data sovereignty requirements?
Industrial controls have been kept separate from the internet for a long time for a very good reason, but now it seems like there's going to be this sort of inevitable merging when you're talking about IoT and being able to, there's clearly business benefits from being able to access and process all this data, but I also feel like we're opening up a whole can of worms and security risks, and on the IT side, we haven't had much success in terms of actually protecting systems and data. What happens now when I can touch an industrial control and shut down a factory or take a plane out of the sky or whatever? What are you guys doing on the GE side and also the HPE side to address these risks that is different from what's already happening in IT?
So a very simple answer to it. Well, I'll start off by saying a couple of years ago, GE acquired a company called WorldTech. WorldTech's industrial grade firewall solution is aimed at solving a portion of that problem, right? And specifically, it originated post Stuxnet. So Stuxnet was probably the biggest industrial control system breach in recent history that caused tremendous impact. And so WorldTech's aim is industrial grade or industrial specific protocols, i.e. 62243, I believe. But they're expanding their compliance and signature set. And basically the solution is aimed at putting it in front of those industrial control systems so that data throughput that comes in and out, ingress and egress, is monitored and tracked through that firewall. It's slightly different than the IT house. On the enterprise side, where we're dealing with your standard firewall, port configurations and NACL protocols, this is more tailored to traffic patterns and anomalies and signature detection that are attacking industrial control systems. Is it a perfect solution? No. Is there a lot of room to grow, especially when you get into data encryption and transit at rest? But the real risk here is who can take control of that asset and cause detrimental impact to a mission-critical environment. And that's where that solution hopefully comes into play.
Well, and it's similar. So what's very interesting, and this is another one of the synergies that we've found via the partnership, is the way WorldTech approaches that is very similar to what you've heard between a combination of ClearPass and now Niara, right? But between policy management at a different level than just how do I configure the boxes and set up my network. It's a software-defined policy management. So back to your example, within the World Tech space, I could allow traffic to flow from left to right or right to left, but because I can do deep policy and packet inspection, I can have a rule that says I never accept a shutdown command from here to here. So I can be very specific to say, yes, I allow this sort of traffic, but these certain key critical commands we shut down and don't allow to come from any of these other sources except for, so you have the ability to be pretty precise about that within the World Tech space. And we found a lot of similarities with that in what we're doing in ClearPass and Niara. And I'm not going to say too much other than watch this space, and I would expect to see these worlds coming together sooner than later. And there's some real unique market opportunities if we get that right.
One last comment on this. We're technologists, but security is about people, process, and technology, right? And so we have people in place within GE. So there's a whole incident response network and community and forums that are specific to the OT space, trust, ISOC. We participate in those. We've got a seat at the table as GE around that. So we understand that area. We also have Red Team members in Israel. Many of these guys are former military officers in the Israeli army. And so we're hacking our own stuff constantly, looking at predicts, making sure that we've got resiliency and security built in. So we're taking not only the technical on-premise approach around the edge with the customer, but we're also looking at it in different vectors, making sure that we're participating in the right communities, but more importantly, actually, trying to break our own stuff before somebody else tries to break our own stuff.
The last thing on that one, I would say if you went into most OT factories and they say they're air-gapped and they're not connected to the IT side of the house, 99.7% of the time, if you put a sniffer on the network, they're connected. Just didn't realize it. Somewhere along the way, somebody put something in place to allow an engineer to dial in from home at 3 in the morning. And to do that, they hopped across the IT network because that's the only way they knew how to make it work. So the idea that, and I agree that if you go, and when you go meet with the customers, and you guys see this even more than we do, they'll tell you it's air gap. They tell you the two don't touch. In today's day and age, they're always touching, not to mention the fact that people are walking around the factory with smartphones and USB, and the problem's really already there. It's just people aren't even watching it.
Well, this is where I come back, and again, I'm going to just take a liberty for another moment. This is where I kind of come back to the box huggers, right? Mentality where people think that if they can see it and they can hug it, it's secure, right? In this day and age, that's not true, right? I love to tell a story of my kid. These guys already know he's a Red Team member. He's fresh out of college, and his first 2 assignments were one with a mid-sized bank in the East Coast, and another one actually I think it was a casino. And by Wednesday, in both those engagements, this kid who's fresh out of college had basically got into their network, right? The people who think they've got the sophistication around security in today's day and age don't, right? You really do need to rely, I think you need to rely on people who have the relationships that we do as tech companies and IoT companies. You need to rely on the experts. And I think we're looking at problems at a different level than people are. So I understand the concern about connecting the two, but to Tripp's point, they're already connected. It's just nobody's actually really looking at it closely.
Sure, and I get that. I'm curious, I'm wondering if there are new or different models, because we know about the IT security models and where they work and where they don't. If you try to apply that to OT or the industrial sector, are there different ways we should be thinking about it or doing things versus trying to take models that have known flaws and patch it onto very critical systems?
Yeah, I mean, think about your classic enterprise network diagram, which basically has the DMZ, which is walled off by 2 different firewalls, and then you do some sort of packet inspection within that to figure out, hey, what signatures are coming through, and can I identify something that is malicious, right? And there's a whole host of models around that basic structure. When you look at the World Tech solution and where we're getting to, it's actually it creates its own DMZ within the internal network itself. So you actually get to let me say this. One of the biggest challenges is network transgression when you actually do get in, right? Somebody gets in and they can transgress your network and get all around whatever they need to find more sensitive information. That becomes the biggest problem because it's sprawling. What WorldTech is aiming at doing is we have two levels. We have one on the higher level ingress, and then we have another one specific to the asset and manages that particular asset on the firewall level. And so if you plug a USB port, it doesn't get out, right? That traffic is inspected on the out. And then when it's coming in, and if let's say it does make it in past that second level, it is walled off at that asset. So only that asset's affected. So really the model is not so much about should I do a DMZ or not. It's really preventing network transgression if something does happen. Because today we basically just say, we're going to protect, it's kind of like an onion. We're going to protect the perimeter, right? And it's going to be layers until you get to the most sensitive data. The layer model that is applicable on the enterprise side is even deeper on the OT side, which is where WorldTech is trying to get to right now. That classic DMZ model, I think, will have to change over time. When we think about the platform and Predix, that's a different security model than at the asset layer, right? So those two will be different for the time being.
So going back off of security, because we just like to move fast, and who cares about security? Exactly. Let's talk a little bit about the compute model. This is A16Z Levine said that edge computing is going to kill the cloud, and you guys are kind of coming back with something a little bit different, which is edge computing in combination with a cloud platform. So let's talk through the management of that, because it sounds like what you're giving me is a PaaS platform to develop my applications upon, and that control plane is pushed down to the edge. Practically, what does that look like from a infrastructure perspective? Are you guys providing all the edge compute, software, etc., the data center assets, and managing that as a managed system within my environment, or is it a combination relationship between IT? What's the operating model of that?
Yeah, I mean, it's Tripp and I were just joking a little bit. It's kind of all of the above, honestly. Together. Edge compute eating the cloud, I think, is an interesting concept. I guess my spin or my interpretation would be that it's a hybrid, right? There are use cases that are going to require the compute capacity of cloud. And there are low latency data sovereignty reasons, well, maybe not data sovereignty, but low latency reasons why I need to make a mission critical or life impacting decision on the edge, right? So it's really use case driven. In my opinion, when you look at where edge computing is going, it will get beefier because the analysis to do predictive decisions will need to be more computational, more compute intensive. And so it will get there, but there is always going to be a need for the cloud to make a bigger decision. Now, when you get back into like an application or a UI, that's where I say it's kind of all of the above together, because eventually you should be able to run an on-prem or a local application if you want to manage, let's say, a massive wind farm. But if you don't want to do that locally because you don't have any data sovereignty reasons, or you are cloud, maybe you want to run that in the cloud environment, those data sets should be available for you to make that decision, right? So when you do the analysis and the decision making on the edge side, that data set should then push to the cloud environment so you can run a more global application to manage a more holistic view of your asset base. Does that make sense?
If your asset is complex enough, and I know Dr. Tom is going to get as much compute power at the edge as possible, just ask him, right? And he'll tell you that, which is fine. But when you start talking about high performance compute and some of the real neural capabilities that are necessary for these massively complex assets. I mean, we were talking a little bit last night about one of your plants in Greenville and just the size and scale of one asset that you deal with and the amount of man and machine power it takes just moving that one asset through a plant. Something that large, inside of it, you're talking about tens of thousands of sensors, right? And so if you're trying to recreate that sort of asset in a machine fashion, right? There's different levels of compute that are going to be required. And the other thing, and this is a little odd for somebody from the technical side of the house or whatever, but there's a lot of backwards, and I don't mean this in the wrong way. OT technology, a PLC is like a printer from 40 years ago. You know, open it up and look in the circuit boards, right? So they've got a long way to go before suddenly they jump from where they are now to the latest in IT, right? There's going to be, and the machinery within those factories and industrial settings, many of them still have 20 or 30 years on their existing lifespan. So you're going to have to sort of retrofit and pick the pieces. I look at that industry and it reminds me of where ERP was 30 years ago, right? Or maybe 30 years is too far, but you had these DOS-based systems and you had a GL and somebody built a general ledger and somebody built an AR and somebody built accounts payable, and each of those were sort of independent solutions and they were huge advancements on their own. And then somebody stops and goes, I'm going to put all that together because there's so much synchronization that needs to happen. And you had a 20-year wave of that sort of working its way through. And that was finance people that are actually fairly technical, right? On the industrial side, you've got a similar wave that's got to come. And you've got lots of distinct silos that kind of have to come together. And it's going to take a varied combination per customer, per industry, per use cases, mixing technology in the right places to solve it. I went to a factory with GE in Modesto, California, where they make filters, oil filters, fuel filters. If you drive a Chrysler, a Ford, a John Deere, you've all had those filters in your vehicle. You just didn't know it was all coming from the same place because they brand them. Those are factories that just having a cloud connection to connect 3 or 4 things is a huge advancement, because they had no automation at that level. Now, there was plenty of mechanical automation, but not technical automation, right? When the filter came off the line and it would no longer had cellophane on it, you hit the stop button. Where's George? Anybody seen where George is? So they start making the call. Yeah, he's 3 buildings down. It'll be 30 minutes. The line sits there for 30 minutes till George can come and put a new cellophane roll on, right? And that seems odd, but that's not like a one-off. So each of these have environments spread out that may or may not even be connected in a lot of ways. So what we've been working on is how to create a set of standards that can then get put together in the right combinations depending on what the customer needs, depending on the location, depending on the industry, the regulation, the sovereign, et cetera. Right? So all the examples you gave are configurations that we're probably talking with joint customers about right now already.
And just a finer tooth example, take the aviation industry, right? 10 years ago, we collected 3 snapshots within a flight: takeoff, cruise, and landing. That snapshot equated to about 5 to 10 kilobytes of data. Easy enough to compute. Fast forward to where we're at today, we can take we get about 5 gigs, or 5-ish gigs, and we take a snapshot every second throughout the entire flight. Now, when you're actually in flight, edge computing makes sense because you want to make low latency, real-time decisions. You probably aren't connected to push things back to the cloud, and you want to adjust the current flight. But when you multiply 5 gigs of data per flight, 30,000 flights a day, 15 airlines across the industry, and all of their entire fleet, that amount of computation doesn't necessarily need the latency, but it needs computational power. That use case, to me, unless you're running your own data center, which may be true, seems like a use case you would push to cloud and have the analysis done there. Right? So those are examples where low latency, limited data sets, real-time decision making makes sense for edge. But when you expand out to the data sets we're talking about in the petabytes, cloud seems to be a viable option today.
So I use that same example in many of my presentations when I talk about IoT. So to give you some real numbers, so if you take all of the Boeing 787s globally, all of the different carriers, it's about 40 petabytes a day of data using the GE NX90 engine. If you use that same, assuming that same kind of data feed off of just Southwest's fleet, which At the time when I put the slide together, 607 planes. 607 times 2 engines per plane comes out to be 256 petabytes per day for Southwest Airlines, one company. So just think about how you're going to consume 256 petabytes. So just give you some specifics there.
No, those are good data points. I'd love to see that page too.
So I guess the next question is, I love the ERP example because that was a great blast from the past, and a lot of that heavy lifting had to be done internally. So you had all these MRP type apps as a result of it, and eventually SAP, PeopleSoft, Oracle, and we have what we have today, which now we're trying to transition that to a cloud type model. The advantage that we have today with OT and IoT, IT combining, is that we already have the cloud today. So coming into this industry fresh, I'll look at it and say, you know what, I'd just like to have an abstraction where I guess the simplest and dumbest way to look at it is look at AWS with their Snowball Edge and say, ideally, you know what, I'd love to just plop a bunch of Snowball Edges down in my the example that they gave, Snowball Edges down in my wind farm, do some Lambda code, and whenever I do need to upload that stuff to the cloud, you know, I ship a node off to AWS and ingest it. Help us kind of expect. I'm not going to use the word double click, so let's say help us go deeper into that and pull back the layers and understand the breaks and complexity, and when fantasy kind of meets real life. Where's the market in maturity of when that abstraction breaks, and when is the example of 10,000 pieces of 10,000 sensors for a 4-node cluster just isn't going to be enough.
Yeah, well, and then the other thing, and actually I'll start with your wind farm example, and then you guys can correct me, but I think we walked through this one enough times, I feel good about it. So even in that example, the use case where I want to collect all that data and then ship it off is a certain use case, because with a wind turbine today, or at least the way the ones that GE's now rolling out, they're looking at all of what's going on in the weather patterns at that moment, and it's self-adjusting and shifting its positioning, the level of the wings on the fan to maximize the output at that point in time. So for that part of the compute, you've got to have it all right there locally, because you're making real-time adjustments based on what's going on. And if you've got X amount of these turbines spread out over acres, what's happening in the front corner of this one may be different than what's happening in the back, right? So again, it's a use case driven model where there's certain scenarios where I need enough of that compute power there to drive certain activities, because there's a certain efficiency in trying to maximize my production that I'm trying to drive. Now, a condition maintenance looking for anomalies across a larger fleet over a larger amount of time, that becomes a use case where collecting the data over time, shipping it off, and being able to run it through, I don't know what I'm looking for, but I want somebody to run correlation analysis through all of this data to see if there's nuggets that I'm missing. Then that use case really matches up to the collection piece, right? So
and then you put another overlay on that. Is it winter or is it summer? If it's summer, oil or energy prices are up, I may want to push that wind farm a little bit harder. I might want to give those wind wind turbines a little bit more latitude to push harder, because I'm going to make more money. Yeah, I'm going to have to move but you can do the real-time analysis. I'm going to need to move my maintenance window in. Right, and so you want to do that analysis to determine is it worthwhile, or maybe you shut some of them down because oil price or energy prices are down, right? And it's the winter season, so we want to push that maintenance window out. So it's a lot more than just a couple of Lambda calls, right, and pushing data up to the cloud when you think so. There's a lot of work that needs to be done there on-prem.
The other thing too, and we'll wrap it a little bit, I think, is your objection of dropping in some snowballs from AWS is what we're trying to aim at, right? The whole point of Predict's platform is to make it easy for the end user to build their own custom applications, very simplistic. right? So we're trying to abstract away a lot of the complexities of the IaaS and the PaaS portion so that you can focus on the data analytics, the data management, and ultimately the applications that come out of it, right? We started to build those functions that you can just call in, and that's where the microservices come in as well, and reusable analytics. So again, you can start to plug and play these components through an API layer that allow you to create a more sophisticated app very quickly. That's our ultimate goal as well.
Well, we're going to bring it to a close here. Thanks very much, Tripp, Anthony, and Geetas for exposing some of the GE Digital IoT. We will be back very shortly with a smart cities focused IoT, but we'll take a quick break right now. Thanks very much, guys.